Okay, this is a quick review of how to use completing the square to go from standard form to vertex form for a quadratic function. Okay, so there really are times when you need to know the vertex of a quadratic that is written in standard form, and you can use this process of completing the square to rewrite it into vertex form. Now, the best way to understand how to do this is with examples. So we're going to jump right in. We're going to rewrite this quadratic function that is in standard form into vertex form. Now we're starting with something that's in the form ax squared plus bx plus c. So let's see what we do. Now we don't need to execute this first step this time. But if a is not 1, then we need to factor it out. But we got lucky this time, we can skip this step. Now, step 2 is to take a look at the value of b, which in this case is 16. We're going to divide b by 2 and then square that whole thing. In this case, that gives us 64. You can see the math there. Now we're going to add and subtract 64 to the standard form function. Here's what I mean. We're going to split it up a bit. We're going to add 64 after the first two terms and subtract 64 after the last term of our original standard form equation. Now comes the magic. We're going to take x squared plus 16x plus 64, the first 3 terms, and we're going to rewrite that as a perfect square. Now, a perfect square is anything that's multiplied by itself. Like 25 is a perfect square because it's 5 squared. 16 is a perfect square. It's 4 times 4. X squared is x times x. All of those are perfect squares. And so is this expression we're about to create. We're going to write it in the form of x plus b over 2. Now that includes the sign of our original b value and everything. So our b value was 16, b divided by 2 is 8, so our perfect square is x plus 8 squared. X plus 8 squared is equivalent to the first 3 terms you see in step 4. Now we still have our minus 9 and minus 64 hanging out there. So our last step is to combine those. And when we do, we get negative 73, and voila! We have our original standard form equation now written in vertex form, and we can see that the vertex is negative 8 and negative 73. Pause now and take notes. Now this is our next example. In this example, b is odd, so we're going to end up with fractions, but really, it's not too bad. If I were you, I would stick with fractions because I think they're easier when it comes to squaring. Let's see what I mean. Again, we don't have to worry about step 1. A is 1. So we go right to step 2. We're going to calculate the value of b divided by 2, and we're going to square that. Now, in this case, b over 2 is negative 3 over 2. We're going to square that and get 9 over 4. Now, keep in mind, anytime you square a negative number, you get a positive number. Because, think about it, a negative times a negative is a positive. So this is always going to be a positive number. And in our case, it is 9 over 4. Now, we're going to add and subtract our 9 over 4 to the standard form function, just like we did in example 1. So we're going to add our b over 2 squared value of 9 over 4 to the first 3 terms and subtract it from the last term, like so. Next, we're going to rewrite those first 3 terms as a perfect square in the form x is x plus b over 2. Now, take a moment and look at the value of b. It's negative 3. So we end up with x minus 3 over 2 squared. That's our perfect square. And last, we're going to combine those last two terms. They end up being 7 over 4 minus negative 7 over 4. And so this is the vertex form of the standard form equation we started with. All right. Now, what does happen if a is 1? Well, we need to factor it out. And I wanted to include a couple of examples of that because you will definitely see that on quizzes and tests. So here we go. We're going to factor out a. Literally, we just factor it out. Now, we got to be careful about our factoring and make sure we do all of our arithmetic right, but it's no different from any other factoring out a greatest common factor that you've done in the past. And so this is what it looks like. From that point on, we follow the process exactly as we did in the first two examples. We're going to calculate b over 2 squared. And in this case, we're talking about the b after you have factored out the leading coefficient of 2. And so we end up with 4 divided by 2 squared, which of course is 4. Now we're going to add and subtract it to the standard form function. We're still talking about the standard form function that is inside the parentheses, and this is what it looks like. We're going to add 4 to the first two terms and subtract 4 from the last term. Next, we're going to just go ahead and create our perfect square. Now, x squared plus 4x plus 4 is x plus 2 squared. So we write it that form x plus b over 2 squared. And b over 2 in this case would be 2. So we have x plus 2 squared, and we have those last two terms still hanging out there. Now we're going to simplify those last two terms, add them up. That's going to give us negative 9. And then we're going to distribute the 2 back across the squared term and the constant. Now our squared expression is x plus 2. So we're going to end up with 2 times x plus 2 squared. And when we combine the last two terms, we ended up with negative 9. If we distribute the 2 to negative 9, then we get negative 18. This is the vertex form of 2x squared plus 8x minus 10. And last, let's look at an example where a is not 1, it is negative 1. Now we can't even have a negative 1 here for this to work. So I did want to show you this case. So we're going to factor negative 1 out, and when we do, you notice it does change some signs in our quadratic. So be careful about that. Don't mess up that arithmetic. Now once we factor that out, it's going to hang around until the end, but we follow our normal steps. We go find b divided by 2 squared. That's going to be negative 3 squared, which is going to be positive 9. We're going to add and subtract that to our standard form function. So we add 9 to the first two terms, subtract 9 from the last term, just like we did before. Now we're going to write x squared minus 6x plus 9 as a perfect square. And we're going to use the format x plus b over 2, while b is negative 6. So negative 6 divided by 2 is negative 3. So we end up with x minus 3 squared. And we have our last two terms hanging out. Now our last step is to go ahead and combine those last two terms. We're going to end up with negative 34. And then we're going to distribute, sorry, that's a typo, the negative 1 across the squared term and the constant. So we end up with negative 1 times x minus 3 squared plus 34. Now that is the end of this video. I hope that clears up some things for you. If you still have questions, please feel free to email me or come see me. And if I'm not tutoring, I can point you to the person who is. Peace out, peoples.